So we're going to try to explain in a little more detail the specification of Jevko, which is available at the jevko.org official website of Jevko, and this is where I'm going to be reading it from, but it's also available on GitHub under this link. It's the same, the exact same content. It also has syntax coloring, so whatever is preferred is good. And we're going to just start looking at the introduction here, and we're going to explain in detail what it says. So it starts by saying that Jevko is a versatile minimal syntax for encoding tree structure information. And what's that about? Well, let's look at an example. This is a piece of data encoded in Jevko, and as we can see, there's a lot of square brackets, which is the defining feature of Jevko. Let's say we can recognize Jevko by the presence of many square brackets. And the way this works is that the entire thing that we see here is itself a tree, and it has branches. In this case, at the top there is only one branch, which is kind of has a label pet, and inside of this branch there's another tree, and it has some branches, a few branches of its own. Each branch has a label, and some of these branches have no further branches inside, and they just end. We could call them leaves, and they may contain a label or a piece of text in them. And some branches have further trees embedded in them, and this particular tree looks a little different than the previous trees because the branches here don't have any labels. So it looks more like a sequence of some values, and these values happen to be themselves trees, and those trees do have labels on the branches. And finally, those branches end with leaves. So we can see that the structure of this thing is fractal, because we have trees within trees within trees, and each level is similar to the previous level. So it's like a self-similar kind of thing. And well, it turns out that with this sort of encoding, we can represent virtually any sort of data. We can actually think of everything that we deal with in software development at a certain level. We can think of it as trees, because even the programs that we write, if we write in a high level language, we essentially, programming is composing trees. So we write some source code which has a tree structure, and we feed it to a program which either runs it directly or walks this tree and executes instructions that are encoded by this tree, or translates it to maybe another tree representation, which is then transformed into something else, and eventually we end up with some machine code or something, or some other virtual machine bytecode maybe. And in the same way, the programs that we write for doing anything can also be thought of as tree processors. So we can always represent our input as trees, and we can think of our program as made of trees, and the output of this program is trees again. So we can connect many of such modules together, and on this level of thinking, all that happens is just processing trees. It's trees all the way down, we could say. And in this way, we can look at data interchange formats, we can look at configuration formats, we can look at text markup formats, and all of these can be implemented with the help of Jevko. So basically the applications of the syntax are unlimited. So briefly, going back to this example I was describing, I should mention that I was not being completely accurate and using the strict terminology that's used in this specification, but that's in line with what I was aiming for here, and we shall straighten things out as we go further along. But this is I think a good enough overview, I would say, and I hope that it does give the general feeling of what this first part is about. And that's it for now. Thank you.